Good morning students, welcome to our online video class of chemistry. In previous class, we had learned about matter. What is matter? Matter is anything which have mass and occupies space. And it is classified on the basis of physical and chemical properties. On the basis of chemical properties, it is classified as mixtures and pure substance. And the mixtures are subdivided into homogeneous and heterogeneous mixtures. Pure substance are subdivided into elements and compounds. And the physical classifications are solid, liquids and gas. Next, we are going to study about properties of matter and their measurements. And measurement in chemistry. Why measurements is important in chemistry? Chemistry is an experimental science. Like all branches of science, experiments in chemistry involve both observation and collection of quantitative data. The data collected of a wide variety of processes are processed and analyzed to establish certain relationships. Such relationship strengths and similarities help the scientist to postulate theories. Thus, it becomes quite obvious that the measurement is a very important aspect of any experimental science. Properties of matter and their measurements. Every substance has unique or characteristic properties, and these properties can be classified into two categories. First one is physical properties and chemical properties. Physical properties, the properties which can be measured or observed without changing the composition of the substance, are called physical properties. For example, color, odor, melting point, boiling point, freezing point, density, etc. Physical properties can be measured or observed without changing the identity or composition of the substance. Example for physical property is freezing of water. When water freezes, it is still water. What is the formula of water? H2O. When water gets freeze, is there any change in its composition? No change in its composition. Only change occurs for its physical state. It is an example for physical property. So, what is physical property? Property which can be measured or observed without change the composition of the substance. Chemical properties, the properties in which a substance undergoes change in its chemical composition, are called chemical properties. For example, characteristic chemical reaction shown by any substance such as combustibility, flammability, acidic or basic nature, reaction with the oxygen, water, etc. For an example, formation of rust is a chemical change. How the rust is formed? Iron react with the oxygen in presence of water. So there occurs a chemical change. What is the difference between physical and chemical properties here? The measurement or observation of chemical properties requires a chemical change to occur. Measurement of physical property doesn't require occurrence of a chemical change. I hope you might have understood the difference between physical and chemical properties of matter in measurements. chemists describe, interpret, and predict the behavior of substances on the basis of knowledge of their physical and chemical properties, which are determined by carefully measurements and experimentation. In this section, we will learn about measurement of physical properties. Quantitative measurement of properties is required for scientific investigation. Many properties of matter such as length, volume, area are quantitative in nature. What are the quantitative properties of matter? Length, volume, area, etc. Any quantitative observation or measurement is represented by a number followed by unit in which it is measured. For example, length of room can be represented as 6 meter. Here 6 is the number and meter denoted the unit in which the length is measured. From the example, we can say the measurement of any physical quantity involves the comparison of its magnitude, that is size, with a standard of same kind. The standard are fixed arbitrarily, but there is always a logic behind such a choice. The arbitrarily fixed standard is called a unit. To express any measurement, one should know the unit in which the quantity is measured and the numerical value of measure. This numerical value gives the number of times the unit is contained in it. For example, while measuring the length of piece of cloth, we should know the unit in which length is measured. That is, whether the length is measured in meters or feet. The number of units in the whole length of piece of cloth, that is the number of meters or feet in whole length of piece of cloth. For example, the length of given piece of cloth is 2.5 meter. That means that 2.1 meter are contained in the length of the cloth piece. The unit in this case is equal to 1 meter. Earlier, two different systems of measurement, that is, the English system and merit system, were being used in different parts of the world. The English system of measurement units includes inches, feet, ounce, etc. These are not used in science because it is difficult to convert it from one unit into another. The most convenient system of measurement is merit system, which is originated in France in 18th century, and it was based on decimal system. Late need of a common standard system was felt by the scientific community. Such a system was established in 1960. To make the measurements more scientific, convenient and uniform, based on the metric system, a new system was established in October 1916. The International System of Units, the SI units. And this was established by 11th General Conference of Weight and Measurement. The SI unit system has 7 base units. Next, we are going to study about the 7 base SI units and their definition. International System of Units, there are 7 base units. The 7 base units are length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminance intensity. Length is represented by the symbol small letter L. The name of the SI unit of length is meter, and it is represented by small letter m. mass. The symbol of mass is m, and the name of SI unit of mass is kilogram, and the symbol for SI unit of mass is kg. Time. Time is represented by the symbol T, small letter T, and the name of the SI unit of time is second, and the symbol for SI unit of time is S. Electric current. Electric current is represented by capital letter I, and the name of SI unit of electric current is ampere. Symbol for SI unit of electric current is A. Thermodynamic temperature, and it is represented by capital letter T. The name of SI unit of temperature is Kelvin, and symbol for SI unit of temperature is K. Amount of substance, and it is represented by small letter n. Name of SI unit is mole, and the symbol for SI unit of amount of substance is mole. Luminance intensity. It is represented by I nu, and name of the SI unit of luminance intensity is candela, and the symbol for SI unit of luminance intensity is CD. The definition of these 7 base units are given in the table. First is length. The length is represented by small letter m. The base unit of length or distance is meter. A meter is defined as the distance travelled by light in vacuum during 1 by 299,792,458 seconds. Next is mass. The unit of mass is kilogram. A kilogram or kg is equal to the mass of platinum iridium cylinder known as the standard kilogram, kept at the International Bureau of Weights and Measures at Sevres, France. Next is time. The base unit of time is second. A second is defined as the duration of 9,192,770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. Electric current. The base unit of electric current is ampere, and it is represented by capital letter A. It is defined as the magnitude of the current that when flowing through each of two long parallel wires of length equal to 1 meter, separated by 1 meter in free space, result in force of 2 which results in force of 2 into 10 raised to minus 7 Newton between two wires. Temperature. The base unit of temperature is Kelvin, K. The thermodynamic scale in which temperature is measured has its zero at absolute zero and has a fixed point corresponding to 273.15 Kelvin at the triple point of water. Amount of substance. The base unit of amount of substance is mole. 1 mole contains exactly 6.022140076 into 10 raised to 23 elementary entities. This number is the fixed numerical value of the Avogadro constant. Amount of substance of a system is a measure of the number of specified elementary entities. An elementary entities may be an atom, molecule or ion, etc. Luminance intensity. The base unit of luminance is candela. Candela is defined as the luminance intensity of 1 by 6 lakhs of a square meter of a radiating cavity at the freezing temperature of platinum 2042 Kelvin. I hope you might have understood what we learned today. We learned today about measurements of physical quantities. In next class, we will discuss about some physical quantities such as volume, density, mass, temperature, etc.